welcome back to my channel. So in the last video we were talking about application of integrals. So this is the second part of it, and we'll be doing some more problems to understand how to find the area using integrals. So let's first start with the first example. So we need to find the area. I'll just write down the question. Find the area bounded by the curves y equals x square and the line y equals 4. So here, if we draw the graph of this function, so it looked something like this. We have the y-axis and the x-axis, and here we have this function x square equals y and the line y equals 4. So let's say y equals 4, this is the line and this is the function, this is the graph of the function. So we need to find the area enclosed by this function, that is between the line and the function, this much area. But what we were used to doing is that we used to integrate with respect to x. Now if I say that here, we know that 0 and x will be 2 because we have x square equals y. So if I integrate between 0 and 2, I'll get the area under this curve. So but we need the area bounded by this line and above this curve. So it's like area under this line and between this curve. So that's why what we can do is we need to apply the limits of y, the values of y, and integrate with respect to y. So we can integrate it, the y values of y being from 0 and 4, right? These are the limits. See, y is 0 here and y is 4 here. So now we have the limit set, and we need to just write down the function in terms of y, that will be under root y, and integrate it with respect to y dy. So the area comes out to be 32 by 3 area units. So now we understand that where we have to apply the y limits and where we need to apply the x limits. So let's solve another question. So we need to find the area between two curves. So before we begin, let's see how to find the area between two curves. Let's draw a rough diagram here. So if I have been given two curves, one is like this and another one is like this, and this one is y equals f of x, and this one is y equals g of x, and I need to find the area between these two curves. How do I do that? So what we can do here is that we know that it is intersecting at 2 points at x. Let's say x equals a and x equals b, right? So what we can do is, first we can find the area under this curve. So everything will come under this curve, so we'll get the area, and then we can find the area under this curve, y equals g of x, and then we can simply subtract these two and get the remaining area. So mathematically it can be written as integral. So let me change the color here. So it will be integral of function of x, the top function, and I'm integrating it from a to b dx. I'll get the area of this whole area under this curve, and then I'll subtract it with subtract the area a to b of g of x dx. So then I'll get the remaining area. So likewise we'll solve a similar question. We have been given a question and we need to find the area between bounded by the parabolas y equals x square and y square equals x. So if I draw the diagram of these functions, so let me draw the x and y axis. So here we have, this one is y equals x square, and this function x equals y square will look something like this, and we need to find the area between these two curves, this one. So what we can do here, again as I've shown, we can just find the point where it is intersecting, and x is shown to be 1 here, so x is 1 and x is 0 here. So what we can do is we can first find the area between under the curve y equals x square, and we'll get the area of this whole part, and then we can subtract the area under this curve. This is y equals x square, and so first we need to find the area under this curve, that is x equals y square. So mathematically I can write it as 0 to 1. This is the limits of the x, under root x dx minus the area bounded by the curve y equals x square. So writing in terms of x, it will be x squared dx. So this comes out to be 2 by 3, and this comes out to be 1 by 3, and the area, remaining area, is 1 by 3 area units, right? We don't know the units, but it's area, so that's why I've written area units. So now we'll solve the third problem. We need to find the area enclosed by these lines. We can see the triangle here, and we need to find the area using integration. So what we can do first is let's just draw some lines, get to know the points where they are meeting the x-axis. Let's say this is D, and let's say this is E. Okay, so now for that, what we can do is we can find the area of ABD, right? Area under AB, and then we can find the area under BC line, which will give us the whole area. Then we can subtract it. So we can subtract the area under AC with the whole area, and then we'll get the remaining part, we'll get this area. So first we need to find the area under the curve or under the line AB. And how to do that? We don't have the function of AB, so we know that the function or the equation of a line is given as y minus y naught equals m. M is the slope, m times x minus x naught. We need to find it, and we have been given the coordinates of every point. This is 1 0, and this is 2 2, and this is 3 1. So starting with the line AB, we need to make the equation of this line. So selecting the initial points, initial y is 0, right? Y0 is 0, so we can write y minus 0 equals mx minus 1, right? And m, the slope, is y2 minus y1 divided by x2 minus x1. This comes out to be 2. So therefore we get the equation as y equals 2 times x minus 1. This is the equation of line AB. So similarly we can find the equation of line BC. The equation of line BC is y equals 4 minus x. This is line BC. and then for the line AC we will get the equation as y equals 1 by 2 x minus 1. So now we have got the equations of all the three lines. What we need to do is first we need to find the area under AB and then area under BC and then subtract it by area under AC. Then we'll get the required area. So mathematically it will be written as, first we need to find the area under AB, that will be written as 1 to 2 because x is from 1 to 2, and then in terms of x, writing the equation in terms of x, you get 2 times x minus 1 dx. This is area under AB. Then plus area under BC will be the lower and upper limits will be 2, 3, 4 minus x dx, and then subtracting it by the area under AC, which is given as 1 to 3 1 by 2 x minus 1 dx. So this comes out to be 1 and this comes out to be 3 by 2 and this comes out to be minus 1. So therefore the required area is 3 by 2. This is the area, 3 by 2 area units. So thank you for watching this video, and if you have any doubts you can comment below. Thank you.